Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to continue with two simple examples to illustrate the idea of fundamental theorem 1 and fundamental theorem 2. So this example is asking you to evaluate this integral, and based on this, we know that the small f is x cubed, and I need to know what is the big F in order to evaluate this integral. And obviously the big F here will be x to the power 4 over 4, because you can see that if I differentiate this function here, if I find the derivative, it will be 1 over 4, and x to the power of 4 will be 4x cubed, where then you can cancel 4 and 4, and you will get that this function back, which is x cubed here. The small fx is equal to x cubed. So now we can continue evaluating it properly. So now we have from, okay, first of all, I'm sorry, this is wrong. This is supposed to be the other way around. This is supposed to be 1 and negative 2. Negative 2 is the lower limit, 1 is the upper limit. So negative 2, 1, x cubed dx. And since we have seen that the big F is this one, so this is the big F, so I'm going to write down the entire derivative, which is x to the power of 4 over 4, and evaluated at point 1, negative 2. And this notation basically means that I have to substitute 1 into this function, so I will get 1 over 4, and subtract that with negative 2. Substitute into this function, I will get negative 2 to the power of 4 over 4. And that is just 1 over 4 minus, this one will be positive 16 over 4, and the answer is going to be negative 15 over 4. Now I'm going to tell you the meaning of a negative result that we have here. Now to some of you, you might be confused why the result is negative when we in fact talk about the area. So recall that when you talk about finding the integral of fx dx from point A to B, this is actually, according to what we have seen in the previous video, this is actually having, for example, fx, the curve, and evaluated at point A and B, and you will find the area under this curve. And area has to be positive. So what's the meaning of getting a negative result over here? Now, the meaning of that can actually be seen if you are able to visualize how does this graph looks like. Okay, so in order to explain the meaning, let me just sketch the graph. So it is important that you still remember what you have learned in chapter 1 about sketching some common graphs. So it is going to be useful, especially in this chapter and the next chapter, where you need to actually visualize the problem by sketching these functions. So x cubed will be something that looks like this, something like this. Okay, maybe too much on the curve there. Wait, let me just try and do it again. It will be something, okay, just give me a moment. Okay, something like this, hopefully. So that is x cubed. This is x, this is fx. Okay, so the points that we are talking about are from points negative 2 until 1. So this could have been negative 2, this could have been 1. Okay, so when you talk about point negative 2 until 0, the area is given. The area under the curve represents this one. This is not the area under the curve. It represents this area. So when you integrate, that's the meaning of that. So this is the area given by from negative 2 to 0. And next, this is the area from 0 to 1. Okay, so we have two areas. So the first one is area 1, this is area 2. Now if we go back to the property of definite integral, so the property of definite integral says, this property especially, it says that if fx greater than or equal to 0, that means at this juncture here, if I have this function and if I have this point, so for example from point 0 until this point here, I don't know what is this point, let's say call it A. So you can see that this one is the value of fx greater than or equal to 0. So the integral evaluated here will be a positive result. Okay, will be greater than 0. Now if you see for this one, from this point maybe until this one B, this function here, this is fx, this is less than or equal to 0. So therefore on this part here, the result is going to be negative. And because of that, oh dear god, and because of that, since our function is x cubed here, when you evaluate the integral from -2 to 1 and you get a negative result, the negative here represents the difference between these two areas. So it is not representing the area per se, it is representing the difference between two areas, area A1 and A2, and so that's why you get the negative result. Okay, all right, now let's talk about the next example. Let's go on to the next example, the last example that I'm going to show you in this video. So determine what is wrong with the following calculation. Okay, so in order to determine what is wrong, let us just try and do it on our own first. So first of all, okay, we can see that the limit is correct, lower limit, upper limit. Then we have 1 over x squared dx. 1 over x squared dx perhaps can be written as x negative 2 dx. And so our job is to find what is the antiderivative of this one. Okay, so now let's talk about the antiderivative. So if fx is x negative 2, now the big F here will be x negative 2 plus 1 over negative 2 plus 1. So this is just x negative 1 negative 1. Oh my god, okay, I'm just going to erase this. I'm just going to write down here. So this is just x negative 1 over negative 1, which is negative x negative 1. Now if you try to differentiate this, this function, so if you differentiate that, you will get negative here is a constant, negative 1 is a constant, you can take it out. So if you differentiate x negative 1, it will be negative 1 x negative 2, and you multiply negative 1 negative 1, you get positive, which is then becomes x negative 2, which is what you have over here. So now we know that the antiderivative for this function is this one, which is x to the power of negative 2. So we can go on and write the answer. So that will be x negative 2. I'm sorry. This is the result. The answer is negative x negative 1. I'm sorry. Okay, so the answer here is negative x negative 1. So negative x negative 1 evaluated at point 3, negative 1. So next I'm going to substitute the result here. Negative, substitute the value 3, so negative 3, negative 1. So minus will be positive. Positive, negative 1, negative 1. So I will have negative 1 over 3 plus this one is 1 over -1. Okay, so next that can be simplified as -1/3 minus 1, and this becomes -4/3. So we've got the same answer to this one, -4/3. But according to this example here, there is exactly something wrong with this calculation. So we need to find out what it is. Now, based on what we have done so far, we can't really see what's wrong. Now, let us try and sketch the function. So the idea is that whenever you are stuck or anything, or you want to visualize it better, you can start by sketching the graph. So how does this graph looks like 1/x²? And we have learned that this is a graph that will look like this. It will look like this. So this is something that you have seen in chapter 1. So the graph will look like this, where you can see that if we talk about integrating this curve from -1 to 3, so maybe this is -1, so this one may be 3. So you're talking about finding the curve and finding the area under this curve. Okay, and what is wrong with this graph? So now I hope that you can see there is something wrong with this problem here, because at point 0, the graph is actually, the function here fx is actually discontinuous at point 0, and that is the problem with this question. So based on the fundamental theorem, okay, now we have to go back to the idea of the fundamental theorem. So based on this, it says that f has to be continuous on the interval a and b. The integral can only be obtained provided that f is continuous on that interval. So in this case, from -1 to 3, so the interval is from -1 to 3, you can see that at point 0, the function here is not continuous. So therefore, actually you cannot find the answer to this one. So the answer is actually the integral cannot be obtained, because the integral cannot be obtained. So you cannot actually, do all this process. The integral cannot be obtained because 1/x² is not continuous on the interval -1 and 3. So that's the answer to this example. This example is just to illustrate to you guys the importance of making sure that the continuity is observed. Continuity of function fx is observed. All right, thank you very much for watching, and I hope this helps you with understanding the very basic idea of integration.